Hey everyone, today we start part two of Unit 7, where we're talking about 3D figures, three-dimensional figures. And today we're going to spend a lot of time just identifying them. That is a really important, really big part of this section of our unit. And you may be familiar with some of the names, but you may not really know where they come from. So that's going to be kind of our goal today, besides doing some calculating later on. So the first thing to consider with a three-dimensional solid is two things. You have to identify the base of the figure, and then you have to identify what the sides of the figure are. So to identify the base, we've got two primary examples of what you're going to see. We're almost always dealing with rectangular bases and triangular bases. All right. So that's going to be the first thing to identify. Now, we are going to look at some examples later that have other polygons, other 5 and 6 and 8 sided figures, and we'll talk about that when we get to that point. But the base of the figure is what the figure rests on. So when you hear me say base, you'll know what I'm talking about. Now, the sides are the other surfaces of the figure besides the base. And almost always they're either going to be rectangular or triangular in what we're looking at. So keep that in mind. If it's rectangular sides, we have a prism. If it's triangular sides, we have a pyramid. And we'll look at some of those examples right now. So on the front of your handout, we're going to choose from 4 answer choices which one identifies the figure here. So the first thing we need to do again is we need to identify the base. Now, the best way that I can describe the base is the base is like a slice of bread. All right, and that's going to sound weird. But what I mean is if you were to take a brand new loaf of bread, slide it out of the bag onto the counter, and you picked up a slice of bread, it's going to look the same no matter where you grab that slice from, except for the two end pieces. Okay. But in a loaf of bread, all those slices look the same. They're all the same shape. If you pull it from the front half of the loaf or the back half of the loaf, it's all going to be about the same size and about the same shape. Now, when we look at this figure here, to identify the base, usually you would think, okay, the base is what the figure is sitting on. That's not always the case here. So this shape, which is kind of obscured a little bit, but if you were to be able to see the markings here, it would look like this. We use dotted lines for these edges that we can't actually see through the figure because this is supposed to be a solid figure. But we have a triangle on this end and on the far end. Right now, this figure is sitting on a surface that's a rectangle. So you might think this is a rectangular base. But if we were to look at the base of this figure, this rectangle, and if we were to slice this figure like slices of bread, what's going to happen is that rectangle is going to start to get smaller as we go up. So if we were to take this bottom base, this bottom slice, and compare it to a slice up here, this is going to be a much skinnier slice of bread than it would be down here. Now, I say that because the rectangle is not the base of this figure. It is actually a triangle. All right, and you can maybe picture this as a triangular loaf of bread because if we were to start slicing this like a loaf of bread again, a slice here on the front is going to look identical to a slice here in the back. That's our base. So we have a triangular base. And remember, if we go back here, if it has rectangular sides, it's a prism. If it has triangular sides, it's a pyramid. So we have a triangular base. So we would call this, oops, let me try that again. We'll call this the base. The sides, which it has three sides, one that it's sitting on, and then the two right and left here, are rectangles. So that's a prism. And so our identifier here would be triangular prism. That would be the name of this figure. Now let's look at the next one. So in this one, and again, we're kind of missing some of the markings here that we would normally see, just marking those three-dimensional surfaces and edges that we can't see on the back side of this figure. And in this case, we have sides that are triangles and a base that's a triangle. And so we can say that it's sitting on the base here. That's fine. So this is a triangular, and because all the surfaces are triangles, it's a pyramid, a triangular pyramid. You wouldn't say rectangular pyramid because there's no rectangles there. All right, then we have this shape. We haven't really talked about circles yet, but those have three specific names. This would be a sphere. We call a tube, like a toilet paper tube, that would be a cylinder. And then we do have cones, which are just like ice cream cones. Those would be our three choices dealing with rounded surfaces, curved surfaces, and we don't do a whole lot with those. Primarily, we're dealing with prisms and pyramids, and that's what we're going to practice here today. So please go back to these notes if you need them, but go through the rest of the handout and identify what the shape is before checking the answer key that's included. Okay, now going on to, sorry, just a second here. I lost my place. There we go. Going on to the back of your first handout for lesson 11, we have some different looking shapes now, and they're not giving us answer choices for what the figure name is. So we're going to have to come up with that figure name, but it's still going to be following the same rules. We're going to identify the base, and then we're going to identify what types of sides it has. So I wanted you to be familiar quickly with what the names of the polygons are. So of course, triangle and quadrilateral are pretty familiar, I hope. But we have a five-sided figure. Let's see here. Five-sided, six-sided, 7, 8, 9, and 10. And the names do go beyond that. We're not going to deal with that today. And this is not something that we'll normally deal with either with these other sided polygons. Again, we primarily focus here with triangles and quadrilaterals. So when we look at this, and we look at these next figures, we're still going to have prisms and pyramids, and that depends on the shape of the side of the figure. But the most important thing that we have to do is we have to identify what the base of the figure is. So let's look at the first one here. With the first one, we've got to figure out what's the base of this figure. What could this, what shape could represent a slice of this shape that would always be the same? So it looks kind of like it's sitting on this rectangle, but that's not the base of the figure. If the rectangle was the base, then we would slice this figure in the same way as that base and get all the same rectangles going up the figure. And that's not the case. You can see how these are starting to get longer, and then they would get very narrow here at the top. So not the base. The rectangle is not the base. In this case, the pentagon, we have 1, 2, 3, 4, 5. The pentagon would be the base of this figure. And if we were to slice off one of these pentagons and keep slicing this figure, that's what we would see. We'd see all the same shape. So we have a pentagonal. Now we have to decide, is it a prism or a pyramid? Does it have rectangular or triangular sides? It definitely has rectangular sides. So again, our base is the pentagon. Our sides are these rectangles here. So it's a pentagonal prism. If you look at the next one, again, it looks like it's sitting on this rectangle, but that is not the base of the figure. It's the pentagon here again on the end. So our Pentagon is the base, and then we have rectangular sides. So it's another example of a pentagonal prism. If we look here at the next one, we need to decide the base of this. Now, this one's kind of interesting because it could really be either rectangle. So notice how the edges are all rectangles. These faces here are rectangles. If we called this front surface the base, that'd be fine. We could also call one of these faces on the edge the base of the figure. It truly doesn't matter. It's going to be a rectangular prism. Now, we don't have any examples here, but if we had a rectangular base, and I'll draw it down so it looks like the base there, and all of the other sides met at a point, that means that we would have, let me try a different color here. We would have all of these sides connecting at this point. Then we would have a pyramid because we have triangular sides instead of rectangular sides. So that would be an example of again, the base is a rectangular pyramid. That would be the shape here. This is what makes it a prism, being all rectangles. All right, then again, here we've got a bunch of rectangular sides, and our base has 1, 2, 3, 4, 5, 6 edges. So this is a hexagonal prism. And again, if these sides were not rectangles but triangles, then we'd have a hexagonal pyramid. So go ahead, complete the practice naming these figures before checking the answer key. And now we're going to take a look at the notes page that's included in your handout. This is already filled in for you. It's going to be a very important reference as we go forward. Most of it should be a review, and it's reviewing a lot of these geometric calculations that we do. So we've got a section on perimeter, like you see here, area, volume, and surface area. And it describes what it is. It gives you formulas, examples, what the measurement units are, and related things. Like if we were dealing with a circle, we wouldn't call it perimeter, we'd call it circumference. But I'm not going to take the time to go through these. It's going to be very important for you to review them. I know it's a lot of information, but again, a lot of it's a review. So maybe use this page as kind of a reference when you're asked to solve a question, you're not sure what it's asking, jump back to this page, maybe dog ear the page so you can get back to it quickly and just check out, okay, I need to find the area of a rectangle. Well, how do I do that? And then you jump back and find the example here on this page. All right, so finally, we have some practice, and we're going to be finding the volume of triangular prisms. Now, it tells us right in the heading, these are all triangular prisms. It looks like this triangular prism here, though, is resting on a rectangular base, and it is, but that doesn't make it the base of the figure. Remember, we want the base of the figure to be the shape that we could slice it into and have all the same shapes. So this triangle here on the edge would be our base. And that's going to be very important as we calculate here. And then what we can't see, of course, is that this extends. Try a different color here. This extends, and there's a triangle here on that end as well. So that's what it looks like. The only thing that's missing, and it's only because it copied poorly, is the height of the figure, the height of the base, excuse me. So the height of the base, which would be here on this triangle, it's just copied too dark to see is 8. So that height has to be, and I know you would have talked about this last year, the height of a triangle is the distance from the base of the triangle to the highest point, and it has to be perpendicular to the base, meaning it has to form a right angle to the base. So we need to extend up our height here from the base of the triangle to the point of the triangle, and it's going to be 8 inches. So we'll write that. We'll put a little dotted line there. That would be 8 inches. All right, now we need to calculate. So what we have to do to find the volume of a triangular prism, and this would have been back on the notes page, is we have to find the area of the base, and this works for any of these prisms here. So we have the area of the base. In this case, the base is a triangle. So to find the area of a triangle, that's the first thing we're going to do. We need to get the base times the height and then take half of it by multiplying by half or dividing by 2. So let's look at the base here, this triangle. We're going to multiply the base times the height. This is the base of the triangle times the height and take half of it. Remember, triangles are half of rectangles, and that's why we do that. So here on the shape, we've got base of 12 inches, height of 8 inches. That's what we're going to do. We're going to take 12 times 8 and then take half of it. That's going to be our area. And that area is, I forgot to calculate it. Let's see here, 80, 96, so 48. Let me double check that real quick. 48. Okay. So the area of our triangle is 48 square inches. That's the unit of measurement that we use for area because we're talking about 2 dimensions. So square inches is our unit. Now, the question asks us to find volume. All we've done so far is we have found the area of this base triangle. Okay, basically we found the area of one slice of bread. Now, this is an entire loaf of bread. So we're taking all of these slices, and there's 20 slices there. So we're going to take the area of one slice, and we're going to multiply it by 20. We're going to multiply it by the height of the figure here. And that's going to tell us that the area of the, now we've gone to volume because we're talking about a third dimension now. Now we're saying the volume is 960. Now we're not square inches, but cubic inches, cubed inches, because we have 3 dimensions now. We have our length, or our length and height, and then our third dimension here as well. All right, I hope that makes sense. Please note, it's always telling you the height of the triangle if you can't see it. So this one has a height of 4 on this number 3 triangle here, but you're going to do the exact same process, practice it several times to get familiar. Remember, always find the area of the base, which in this case will always be a triangle. Find the area of a triangle and multiply it by the height of the figure. So in this next one here, you'll find the area of this base triangle, which is those 2 dimensions, and then we're going to have 6 slices of that. So we're going to multiply our area by 6. I hope that makes sense. If I can clear anything up on Zoom, please ask. Don't forget to take a look at your practice problems for today, and I will talk to you next time. Have a great day.